Okay, thank you everybody for joining us. I think this is our last meetup for the year, and I'm really excited to have our speaker here today because I've tried a lot to get him. So we're really glad he's here to join us for this last meetup of the year 2025. So thank you everybody for joining us as well. So today we're going to be looking at reproducible workflow with RStudio Projects, renv, and version control. So what we're going to be having as our takeaway from today's session is participants, you're going to be able to organize your R projects efficiently using RStudio Projects. You're going to be able to create isolated and reproducible environments with renv. And also you're going to understand how to use version control tools such as Git and GitHub to track changes, collaborate, and maintain clean project histories. So together, these skills will enable you to produce transparent, reproducible, and easily shareable analysis. So now let me introduce our speaker. Okay, so Ezekiel is a statistician and data scientist who applies data-driven methods to economics, climate, and health, creating tools that turn evidence into action. He earned his first-class honors in statistics from the University of Ilorin and a master's in mathematical sciences from Ames, Rwanda. He serves as the lead statistician consultant at Redwire Group, where he leads the sampling design and analytics workflow for a multidimensional poverty project across northern Nigeria. His experience spans roles at 54Gene and Data Science Nigeria, where he managed analytics projects for the Bill and Melinda Gates Foundation and the MasterCard Foundation. Ezekiel is an RStudio Tidyverse certified instructor and the creator of R packages like bulk reader and for string R. He authored the forthcoming statistics and data analysis with R, a lab-based approach, and co-edited the Beginner's Artificial Intelligence and Python programming book for schools as well. So he has received numerous awards and fellowships, including Mastercard Scholar, Federal Government of Nigeria FSB Scholar, Unleash Talent, Heidelberg Laureate Forum Fellow, and Capacity Accelerator Network Fellow with the Global Partnership for Sustainable Development Data. He's a passionate open source person that is passionate about open data, reproducible science, and mentoring new R users across Africa. So please join me in welcoming Ezekiel Adebayo Ogundepo. Thank you for joining us today.
All right. Thank you very much. Okay, let me share my screen.
Yeah, we're glad to have you. Thank you.
You're welcome. Thank you very much. I want to share my screen. Okay.
Can you try now?
Okay, please let me know if you can see my screen.
Yeah, we can see your screen, RStudio interface.
Oh, great. Okay, let me try to change it to other theme so that everybody can see it clearly, because we'll be diving into practical session very soon now. Okay, I think this is fine. Oh, great. Okay. Let me share my PowerPoint too. Okay. Please let me know if you can see my screen now. Can you still see my PowerPoint?
Yeah, we can see your PowerPoint now.
All right. Thank you very much. Thank you for having me today. In today's session, we'll be looking at reproducible workflow using RStudio Project, renv, and version control. Before we move into the session, practically, I would like to introduce my forthcoming books, which is the first one is R Programming Fundamentals, a lab-based approach where we dig in into the introductory part of R programming and everything that we help the readers, to be able to navigate the world of R. And then we also have statistics and data analysis with R, where you'll be using several packages, in analyzing data and understanding the basis of statistics. You can pre-order it by visiting this link or by scanning the QR code. So in this session, right, I'm going to explain the concept of reproducibility and why it matters for data analysis. And you also learn how to organize your work using RStudio Project to create a self-contained reproducible workflow. Then you also learn how to use Git to track changes, to your file and using version control such as Git. Then you also learn how to collaborate and share your work effectively with GitHub. Then I'm also going to show you how to manage package dependency using the renv package to create isolated and reproducible R environments. What is reproducibility? Reproducibility is just the ability to obtain consistent results using the same data, code, and computational environment. And it has just three key components. The first one is data, which is clean of errors, version as it evolves, and documented via metadata. Then the code, which is organized into reusable script or function and must be clearly commented, then we'll be able to track it with version control. Then we have environment. For example, the kind of machine you are using may be different from mine, and that is where we'll be using the renv package that will help us create a log file, which will also help us to encapsulate our containers. Why is reproducibility matter? Number one, it helps us to enhance transparency and trust. For example, every step you follow to be able to analyze your data or writing the report with Koto, everybody can easily see it without any doubt. Then it enables independent verification of results. So nobody will be doubting your result because they've already seen how you did everything. Then it helps to facilitate collaboration and interactive improvement. As you can see, with the help of this reproducibility concept, all of these things is what you allow everybody to trust your results. And I have this workshop in 3 sections. And the first one will be talking about the RStudio project. The second one will be talking about the version control using Git and GitHub. And the third section, which will be the last one, will be integrating the renv package into our project so that we can create the reproducibility workflow. Before I introduce RStudio project, I believe that everybody knows what is a working directory. So the working directory is just where I'll look for file that you ask it to load and where to put any file that you ask it to save. For example, when you want to import a particular data, if you don't set up your working directory, you'll be having an error telling you that the data does not exist or I does not know where to locate such a file. And with RStudio, for example, if you look at the RStudio console, that is where you will know where you are working with your working directory. For example, if you open your RStudio, you see something like this. Under this place is your working directory. And you can also check your working directory by using getwd. For example, in my own, I have C :users /admin /desktop /all /gbg book. That is my own working directory. And if you copy this code into your console now, you will notice that your working directory will be different from mine. So nobody has the same working directory. Okay. To also set working directory, right? For example, if you want to set a working directory, this is what the R users always do, in the olden days, where they will be setting their working directory, and you will always see it on at the top of their script. Sometimes you can also use this shortcut, Control Shift and H on Windows, or you use Command Shift, Command, I think is it Command Shift Option and H on Mac, and that will help you to select your working directory and to begin your work. I want to explain the concept of absolute path and relative path, because this will help us to be able to create a reproducible workflow. The absolute path begins the root directory of your file. For example, you have something like this. So it contains almost everything, the path that leads to your C drive. For example, you can see my own C underscore user. Okay, the last one for my own here, if you look at it, this is my absolute path. You can see it leads me to the root, the C drive, and that is what absolute path is all about. Then we now have relative path. This one specifies the location of the file that you want to use in your working directory. As you can see, it will be something like data/data.csv. And with relative path, anybody using the same script or working with you, they will be able to enter into this directory without any problem. Uh, so let's see a workflow, that helps us to be able to use RStudio project. For example, in your RStudio project, when you create it, should look like something like this, where you have your README, your license, if you have a license for, that allows other people to be able to work with you. The report, here is the directory, the file for report. If you have a lot of data, you can easily put your data inside the data directory. For example, here I have analysis directory, and you can see in the analysis I have several files such as my report.qm, which is the Koto file. And if you have any script that you want to put together in the directory of R, then we have something like this. This is just like how the RStudio project, should be structured. And a typical example is what I have here. So I remember when I was working for a particular client on maneuver analysis, that is multivariate analysis of variance. I structure the project in this format. You can see here I have RStudio project, which is .rproj. Then I also have other directories such as data, the report, the resource I use to create such a report, and several scripts I use to be able to analyze the data. So this is what the typical RStudio project should look like. Now, if you want to create your own RStudio project, you follow the following steps. The first one is you open your RStudio, then you navigate to File, then you click on New Project. Under the New Project, you have something like this: New Directory, Existing Directory, and Version Control. So let me explain them one by one. If you have not created any directory for your project, then you click on this New Directory, which will help you to structure everything afresh. But if you have already, working with a particular directory, then in that case, you will select the existing directory, and then you will go to the part where that your project is, which is not RStudio project, and that will help you now create RStudio project. And if you want to integrate your project with version control, then you can click on this one, and this one will now integrate the Git into it. For example, here I click existing directory, as you can see, because I've already created a project folder called Maneuver, but it's not an RStudio project yet, but I want to initialize RStudio project into this folder. That is what I did like this, and I click on create project. Immediately I click on create project, then an RStudio project was opened. Something like this. As you can see, if you have not been working with RStudio Project before, in this place here, it will become like something like empty or none. It will write none. I will show you. Then immediately you create an RStudio project and you launch into it. You will see the name of your project here. And if it's a new project, you may not have anything here, but you just see that you are now in the RStudio project. So after you have created that, maybe you close the project and you want to open the project again. So what you will do is to click on the .rproj. As you can see, it has your project name with an extension .rproj. When you double click on it, then it will now open the RStudio project for you. So let's see the benefit of using RStudio project. The first one is that it keeps the workspace variable and setting confined to the project. Then it also supports relative path, which is easier to manage. Then we have version control is integrated with version control such as Git or Subversion. Then with the help of RStudio project, you can easily organize your directories. The data directory, the report directory, the resource directory, and even the script directory. And you can easily port into any of those directories without any problem. So for every section, we'll be moving into the lab section where we practicalize everything you have just added me. So for example, I'm going to open my RStudio project. So if I click on R, you can see that here is just empty RStudio. And from here, you can see the project is none because we have not created any RStudio project. So if I click on this, you will see several RStudio projects I've created before. For example, my forthcoming book here, all this, Meetup, and many more like that. If you want to create your own RStudio project, as you know, RStudio has several ways at which you can open any file or interact with it. For example, you can come here, click on New Project, so it then open a new window for you. Which you can actually select. And if you like, you can come to this place, click on File, click on New Project. The same thing will also open the same window for you. So here I will be using existing directory. So in this existing directory, then I will click on Browse. Then we go to Desktop. I think I have Abuja R here. Then this is where I want to use as my RStudio project. So I'll just double click on this and then click open. Now you can see this is now the full path to my project. So immediately I click create project, RStudio will create the project into that directory. And if you have been working with a particular RStudio and you have several tabs on the RStudio, then this one is somehow dangerous because it's going to close that one and open the new project for you. So instead, you can just click on this button saying open a new session. In that case, your existing tabs will not be closed, but it will just open another R session for you where you can start working with your project. So I will click create project now. As you can see, it's loading and it's creating a new project for me. Now you can see I am now in the RStudio project. How do I know? This is it. Before it was none. Now I can see the R project icon and I can see the name of my project, data visualization. So here are several scripts I've written to play with in this session. For example, I have data directory. You can see diamonds, art, and US economics CSV. Then I have all of this. So let me close my project so that I can see how to open that project again. So I'm going to click here. So this will close the RStudio entirely. Now, this was my initial RStudio session. I think I don't need it. I can also close that one too. So let me now open it again. I will click on the directory where I have the project. Then this is the project directory. So what we notice is that before there was no data vix rproj, but now because I've already created an R project in it, now I can see this. So if you don't see this, that means that you have not enabled your extension to be shown. So you can do that by clicking on view and click on show, and then you will see file name extension on Windows. So if I off it, you can see I will not see the .rproj. But if I enable it now, you can see I can see all my extension. This is .r, which is R file. It's another R file. This is an image with .png. Then this is my readme md.md, and this is my RStudio project. So to open the RStudio project, you just double click on this guy, not this not this R files, but this one .proj, .rproj. So you double click on it, and now we see your landing on the RStudio project. So if I ask out now that where is my working directory by using getwd, you can see that this is the path to my project, which is what we have here. But if we close this project, let's close the project. Okay. And ask R where is our working directory. So it will take me to the document, because that's the default working directory for my session here in RStudio. But if I want to navigate to that place, without using RStudio project, I will start, using setwd, which is not good to be used on a particular script. Where is it? I have to start going to desktop, go to Abuja or something like that, which is not. So don't let me even show us. All right. The main thing is to move into your RStudio project. So this is my RStudio project, data visualization, and then automatically I will be in my RStudio project. And if I want to import, if I want to, let's say I want to load a particular data using the relative path, what I will do, for example, I can just say library. So let me load library tidyverse, which contains several packages such as readr, ggplot2, tidyr, and many more packages like that. So if I want to import my data now, so it's easier for me. For example, let's look at diamond data. Diamond data. So here now, diamond is it's a spreadsheet file. So what I will do is to load library read Excel, which will help us to load the spreadsheet file. Of course, read Excel is also part of tidyverse, but when you load tidyverse, read Excel is not will not be loaded until you load the package itself. So now it's loading. Okay, this guy is confusing me. Okay, so now the read Excel is working now. So with that now, I can load this data. So don't worry about my copilot. So it's just suggesting the code for me to open the data. So which is this? Read Excel, a function in read Excel package. Then I have this. So if I run it now, it's telling me the path does not exist because the copilot is not taking the directory where the data is, which is data. So what I will do now is to say data slash diamond dot xls. Okay, then I run it. You can see that it now works. So I can look at the glimpse of the data. Oh, it's telling me diamond data is not. What's the problem here? Oh, it's diamonds. Diamonds.xls. Okay, so I can clear my screen. Now I have diamond data loaded for me now. Then I can look at the glimpse of the data. Now you can see that I have 60 rows, 60 observations, and 9 columns. So if I like, I can also look at the head of the data by using diamond data. Okay, pipe it and use head. Okay, so this gives me the first 5 observations, which is this. Okay, so that is just the importance of using RStudio Project, to help us create a reproducible workflow. As you can see, I'm not struggling to import the data because I have the relative part, and without the RStudio Project, I will not be able to use this relative part. I will have to use the full part itself. So we are done with this RStudio Project. Any question for me? Okay, let me look at the charts. All right. Is there any question? Okay. No question. So we are creating a reproducible workflow, right? So and we have already, created our studio project, which helps us to first create the
Hello. Hello.
project directory.
Yeah,
Hello.
hello.
Yes.
Yeah, please. I want to know, like, after creating the project,
Yes.
I've realized that all your documents are in one folder where you can see the diamond SLSS.
Yes.
So after creating the project,
Yes.
how can you organize your work? Because it seems like inside the project, every script, your graph, and everything will be in one that particular project, right?
Yes.
So is there a way of organizing the work to know that, okay, in this project we have this thing for script, this is for the data we have, and this is for maybe the outcome or the outputs, maybe graph and all this. Can we organize those ones inside the project, or we should just allow
Yes.
everything to be in one folder?
No. So now that we have created the project, right? So the next thing is now to structure our directories. For example, I can create, of course, I can use RStudio itself to create a folder. So by coming here, so you click on the directory here, I can call it script. Okay. So there I can then move all of this into that script by coming here. So uh, please select a single file. Okay. So in order not to waste my time, I can just come to the project directory and then move all of this into the scripts. Okay. That's the first one. Then the output, of course, we can also create another directory. We call it output. So here, all this, so we put into it. Okay, even this one, we put into it. And now you can see we have a structure project directory now, right? So this is easier to navigate. And we have the README file, which will help us to understand what the project is all about and how other collaborators, can work with it without you being there. Any question? Okay, is that clear?
Yes, please. Yes, please. Thank you very much, Senior.
All right, you're welcome. Thank you. So now that I've created the RStudio project, so if you want to send this project out, so it's very simple. So what we do is to just zip it, right? You zip it. I'm using Windows. I believe everybody can zip a folder. So I'll just click on I will click send to, and then click on compress zip folder, and automatically it will zip it for me, and I can send it via email or wherever. So I can just send it so that anybody can work with it. Now, when they receive the directory, what they will do is to unzip unzip the directory and start working with it. That's all. Okay. So now you can see, so this is the file I will send to my collaborators. And what they will do is just to unzip the directory and start navigating those files. So we are done with creating RStudio project. Now you can see everything is well structured here, and we can work with any of this automatically. So let's look at the other section which we have, which is reproducibility workflow with version control. I'm going to take us back to Microsoft Word, where you can easily create a track changes, and whatever you are doing, every step you are taking is being recorded so that anybody looking at it can see what happens, and they can accept or reject the track changes. The same thing also happen in version control, right? You can see the track changes. You can even see who your collaborators are, and it's also if there's any error, you can revert back to the original file.
Yeah, senior.
So we'll be okay.
Please, can I kindly send you back small, please, about
All
how you
right.
did the zipping.
I did the zipping. Okay. So I click on the. I'm using. Are you on Windows or you're on Mac? So if I'm on Windows, so you just you click on it, you right click. Then for me, you just go to show more options, and then I'm using Windows, I think Windows 11 or so. So then you click send to, you can see send to here. This is send to, and you can see compress zip folder. So once you click on it, it will zip it for you, and that's exactly what we send to your collaborators. Is that clear?
It means that that folder contains your script and your data you have analyzed, right?
Exactly.
Oh, okay,
Exactly.
okay. Thank you very
So
much.
you're welcome. Let me zip it again so that I can unzip it on my computer, so you will see what it contains. So I click on send to, I click compress, and so I just click it now. Okay. So imagine I now put it on, let's say on my desktop. Okay. So this is what my collaborator will see, right? Maybe I've sent to them on via email. Then they download it. Then they put it on their desktop, so they have something like this, right? So let me close this RStudio. Let me close it. Uh, Call it data import. Okay, let's put it in scripts. Okay, so I'm going to close this guy. So imagine you receive this file. So what we do is just to unzip it. And I can unzip it by coming here, extract all, and click extract. So now you can see here is the extracted directory. So I can close this guy because I don't need it again since I've extracted it. So then I will open this. Now you can see here is it, right? So one thing about Windows is that it will create a double a double directories where you'll be entering from one directory to another. I don't like this. So what I will do is to just cut this guy out and then repaste again. Okay, so that will now remove the outer directory, and I will now have a single directory, as you can see. So here now, you can see it contains everything I have. And to work with this, I will just click out. As I'm an R programmer, I know that this is RStudio project because it contains the .rproj. So to work with this now, maybe the first user, I've structured everything here. Then I'll just open this. Now you will see everything will be here. Okay. And then to understand where to start, then I can read the README. So this README file will guide me to know how to work with the project. So you can see this project demonstrates how to create a clear, informative plot using ggplot2 and all of that. You can see the structure of the project is here. Click on data, click on this, click on that. You can see all of that. And so this will guide me to know how to navigate this. And that is the importance of using RStudio Project to create a reproducible workflow. So let me close this. Right. Yeah, let me delete it. So I believe you now know how to create an RStudio project. You know how to send the RStudio project to your collaborators. If you are a student, you can send it to your supervisor, and the project will guide the supervisor on how to open it. So I come back to my initial folder, which is this one. Then I open my RStudio project again. Now you can see I have everything back, and I can move from one place to another using this panel here, the files panel. You can see this is the data, this is the output. I can see what is in the output. I can even open it. You can see this is the area plot. No, this is the area plot. So this is the scatter plot. I can see what happens in the output. This is the area plot in PDF. Here are my scripts. So if you like, it's good to actually create a, what do you call it, a consecutive script. You can order it so that the person will know I will click here before this. I think there is a particular work we did with a particular client. I don't know. Let me see if I can get it. Uh, I don't know. So take time to look at it, and then because of the sensitivity of the data, so it's good to just number it. For example, you can call this one, you can rename it, and call it. For example, you can just say 1.0. You can order it. This one, you can rename it here. Okay, call it 2.0, 2.22. The second file, and this one you can call it, if it something like this. All right, so then we can refresh. You can see to refresh it, then you click on this guy. Because sometimes when you export the data into a particular directory and you are on this panel, so it will not show you the last operation except you refresh it, and you can easily refresh it by clicking this guy here. So now this is my working project. So, and that is how to create an RStudio project. So the next session will now be for us to understand the version control. Okay, so I've talked about how the version control, was integrated into the either Google Doc or MS Word, right? You see something like this, review, and then you activate your version control. And now let's see how to uh, let's see something about Git. So what is Git? People have been talking about Git. What is Git? So Git is just a distributed version control. and it was created by Linus Torvald in 2015. And it is used just to manage the files for the collaborators so that everything is well documented. And Git is known for its speed, the flexibility, and ability to handle projects of all sizes. And that is why I think Microsoft had to buy this Git with billions of, is it millions of dollars or billions of dollars in those days. We also have other version control such as Mercurial, Subversion, and Paphos. But Git is what almost every company is using. You will see Google using Git, you will see Meta using Git, and in fact, XAI is also using Git. So, and to work with Git, you will need to install it. And you can install Git by visiting their website. For example, git-scm.com/downloads. That is where you now pick the version, the platform that you are using, your machine we now will tell you which one to install. For example, if you are using Mac OS, you just click this guy and it will get it downloaded for you. If you are on Windows, you just click this. And if you are on Linux or Unix, you just click on this. And to know whether you have successfully, installed Git into your system, you are going to use this code: Git space uh, hyphen version, and that will now show you the version that you installed. And if you cannot see that version, that means that your Git is not installed. For example, let me show you on my RStudio. So here, because I've already activated my Git, so I can go to the terminal and see. So it's loading, my terminal is loading. Then I can just say Git, hyphen and say version. Now you can see, so I'm using version 2.4.8. So after you have installed Git, so to activate it on RStudio, what you will do is to click on Tools, click on Global Options, and then look for Git slash Subversion. Then you can see this is the path to my Git. So if you have installed it, automatically RStudio will detect it. So you don't need to start struggling to know what to put inside this place. So once you install it, automatically RStudio will detect it. As you can see, yeah. Then for me, after I install the Git, I also activate my Copilot, and that is what is suggesting several things for me in my RStudio. So you can see I activated my Copilot. I signed into my GitHub, and it's suggesting several things for me. Okay. Any question from this angle?
So I want to know the Git.
Okay.
What do we use it for, particularly in R, like in RStudio?
Okay. That's a good question. So Git, will help us to create what is called version control. So without you initializing Git into your project, if you lose any file or something happens to your computer, you will not be able to restore your files, right? But with the help of version control, you can retrieve it. You can before remember that after I created my RStudio project, I have to zip it, send it to my collaborators. The person then download it, open it on their local computer. But when I initialize Git and I put my code on GitHub, so what I will do is to send the link to the collaborators, and the collaborator can look at everything and they start working with it without me manually sending the project, to him or her. But don't worry, we'll get there very soon. Is that okay?
Yes, please. Thank you.
Oh, you're welcome. Okay, now that you have installed Git, right? So to work with version control, you will need to understand several commands, on Git. For example, uh, to initiate a version control, you will use git init, right? So this will create a Git repository in your current directory so that you can start using several Git commands. And to do that, you just say git init. And so to see your project current state, you can use git status, right? So git status. For example, if I just want to explain all the theories before I start doing everything in my RStudio. So, but for now, let's just create a version control inside this project. Remember, this is our project, and if you use any git command, you see it will throw an error because we have not initiated git on this. Sorry, I want to say git status. As you can see, it's saying fatal error, not a git repository, right? And to create a repository, you just follow that command, that is git init. So immediately I press enter like this, you can see it has initiated a version control on my computer. So now if I refresh it now, you don't see anything here, but if you go to the project itself, you will see something. Now you can see. So this is version control. So this you what we're recording every step you are taking. Every step you are taking, you know, the way you do it, you write several comments. And I'm going to explain all those things later, right? But just know that now we have created Git, we have initiated Git into our project. Okay. So the next command I'm going to show now is git status, right? The git status will show you the current status of your project. So what is happening? Have you added a new file? Have you deleted any file? So it will show you everything, both the stage, on stage, and on track. Don't worry, I'm speaking grammar, but I'm going to explain them one by one very soon. So to add any file into your project, so what we do is to say git add, then the file name. But some people are lazy, right? They don't want to start, adding every file, by just saying git add with the name of the file. So what you can do is to use this command, git add dot. So this will now add all the files into the staging area. Now to commit the file into the staging area, what we do is to use this command, git commit -m, and the name of the message you want to commit, for the file. So that is what we do here. And of course, RStudio, without you understanding all this command, you can easily be, what do you call it, click to get your project, to push it into the GitHub. So, but for now, I just want to show you that you can also use command to do all of this. And I believe no software developer, will be using all this drag and drop to commit their projects. Then you must understand the file state of your project. Remember, we have the working directory. So this is where you have all your files, directory, and everything. Then you have the untracked. So if you have not added any file, so that file will be untracked. If anything happens to it, you have lost it like that. But if you have committed, then it will be in the staging area. Okay. So if everything is fine, right, then you can now push your project into in GitHub, and you can use this command by using git push. So this is what you get your code into the remote repository, such as GitHub or GitLab. Just know that every command you have been learning is also the same thing for GitHub or GitLab. But don't worry, we'll get there very soon. All right, we have what is called branching, right? So if you are working with anybody, on a particular project, you can't just start, dropping or writing on their code. So what we do is to create a branch, right? A branch is just like another version of their project, so that when you are done with your own, then you can start. They can merge it, and they now become one project, right? So, but what we do is to create a Git branch, and to list all the branches in that project, you use this command git branch. So it will list all the branches, and you can switch from one branch to the other. If you have not created any branch, so what the branch you'll be working with is called main branch, and it is not good to be working on main branch, because anything can happen, and you may not be able to recover it. So that is why it's always good to create several branches, and when the project is now in good status, then you can now merge it into the main branch. So this code will help you to switch between branches, and this code will help you to merge the branch into the main branch. Then you also have git branch minus d with the branch name. So this one will help you to delete any branch from the project. So to create a new branch, what we do is to use this code git branch, and then you now name the branch you want to be working with. So here I just say git branch new analysis. Okay, and then so this will create that branch. But to switch to that branch, you are going to use git switch, and then put the name of the branch you just created. And so this is what will help you to enter into that new branch. Alternatively, without you creating any branch, you can switch to a new branch by using this code git checkout minus b and the name of the branch you want to create, and enter. So this will automatically do the two steps together. Okay. Okay. So if you want to merge the branch together, what we do is to go into the main branch first. Then from the main branch, then you can now merge the new branch you just worked on, and by using git merge new analysis, and all the updates in that new branch will now come in into the main branch. If you have been working with Git, and you have been working with your project, so if you want to know the history, all the information, about the project directory, you can use this one line of code: git log hyphen hyphen one line hyphen space hyphen graph hyphen decorate. So this will now show you the concise visual log. Please, I want to have my computer charged. I'm coming. Okay. So this will show you, the visual log of your project. Which one again? When you are working with a Git project, there's no way you will not have any conflict. What is conflict? For example, you are working in a particular file, somebody's also working in that file, and both of you are working together, right? Maybe you want to push, and there will be a conflict, right? And you must know how to solve that conflict. It's actually very simple to solve a conflict. So what you need to do is to click to type key status. That will show you what is happening in the project, and when there is any conflict, you will always see something like this in a particular file, right? So what we do is to find a way to manually edit it, right? Once you do that, there won't be any conflict. Uh, Once you have edit all of this, so what we do is to now add the conflicted file that you worked on, and then you commit your project into the staging area, and everything will work together. So Everything I've been saying since morning is just to help you create a version control on your local computer. Remember that if you have done all of this, everything will still stay in your local computer. But to be able to get it into the remote repository, you will need to have a GitHub or GitLab account. But since GitHub is most commonly used, and I will be working with GitHub, but everything I'm saying about GitHub is also, in line with GitLab. So you don't need to learn anything on GitLab. Just go there and start working because they have similar features. So, but what is GitHub? Everybody is saying GitHub, 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 GitHub. And if you are not a developer, you may be confused on what GitHub is all about. So GitHub is just a website that allows you to store your code on the cloud, right? It is on the cloud. And it is not just a cloud storage, but a version control system powered by Git. When they say cloud, you'll be saying, why can't we put it on Google Drive and start working with it? Yes, you can put your code on Google Drive. But remember, every time you want to update it, you have to start uploading, manually uploading. But with GitHub, you don't need to manually update it. So what you just do is to start using command that will get your code into the uh, remote repository. So why are we using GitHub? The first thing is it is an open source. It is free. So you can create a free account, and it also has several collaborative features such as issue, wiki, and many more. Then it integrates with other tools. For example, many people use GitHub as a project management, tool, because if you are working with if you are working in software industry, it's a must for you to know version control. And the joy is that it has large user community. Almost every our user should know GitHub, GitLab, right? Because if you are collaborating, on a particular package, that package must be on either GitHub or GitLab. So if you don't know version control, it will be hard for you to be able to collaborate with any package because nobody will start sending you their package source, manually. So you must know how to take it from the version from the repository, start working with it, and when you are done with your part, you push it, by creating a pull request. So they look at the pull request to see what you have done is right. Then they merge it, and that is how to contribute to a particular open source project, which GitHub and GitLab allow us to do. So setting up GitHub and GitLab is almost the same. The first thing is to create an account, right? Then you create a new repository. Repository is just your project file name. For example, in our initial project file, we call it a data visualization. So on the GitHub or GitLab, the name of that repository must be the same. So in this case, it will be data visualization. And once you have done that, you can clone it. Clone is just to download, right? So there's a code to clone it. So git clone and the path, the what do you call it, the link. So put it there and automatically it will download it for you. So if you see any project on GitHub and it is not closed, it is open, so that means that you have every access to download the project. In fact, you can work with it, you can collaborate with it. It can even be yours because it is an open source. And after that, you add your files to the repository, and then you commit your changes, and then you push it to the remote repository. So the same thing is what you have in GitLab as well. So if you have not set up all this configuration, you will need to set it up. And to set it up, you have to use this command. Remember, you must have created a GitHub account, and then to set it up, you have to follow this command: git config space hyphen global space user.name. The username is your username on the GitHub, in the GitHub account. For example, my own is GBG analyst, and this one here, user.name. Then under this quotation is where you put your username, GBG analyst. Then your password, Git. Follow this one. Then you put your email there, and that will set it up for you. So let's see how to do that. So for my own, I've already created those things, right? So if you want to do your own, you just come here on the terminal, or you just open your Git bash. Remember the last time you downloaded Git bash? So this is your Git bash, and you can, all those codes, you just put it here and start populating it. For example, let me copy it here. Okay, so just copy this, go to your the Git bash, right click, paste, and then you edit it. Okay, so you just edit it. So here is your GitHub username. The username you create is what you put here. Okay, and press enter. The same thing for the email. But first, let's see how GitHub looks like. So you just go to github.com, github.com. So if you go to github.com, you have something like this. Okay, you have something like this. Okay, then from there you just create your account, put your beautiful and handsome picture, on it, and make sure when you are creating it, you must have something that defines you. For example, your username. You know, it should be consistent. With you. For example, all the way so that people can identify. Oh, whenever they see this username, they should send that it is you. So for my own is GB journalist, and you can see several repository I've created, and yeah, you can easily work with me if you want. So but after you have created the repository, after you have created the account, and you have set up your Git bash, you have configured everything, both the username and the email. Then for the RStudio, if you want to work with RStudio, so what we will do is to come to the tools, click on global options, click on Git/SVN, then this one should automatically detect it. And then you click apply and you click OK. So now you can easily work with version control in R. Okay. So let's see. There is a particular. Let's see. Okay. So now, remember, I have this project. So let's see. I say Git status. Okay. Now you can see all of this. You can see they are all highlighted in red because we've not added them into the staging area. And what we do is to add them, but there's a particular RStudio menu that we're able to do that. So I'm looking for it here. Please, I'm coming. uh, uh, it should be around there, but I'm not seeing it. Coming. Git. What's the problem? Okay. Okay. Now here is it. You can see Git here. Okay. So what I did I think I refresh or I close my screen. Please, can you see my screen?
Yes.
All right. Okay.
I
Any
think
question,
someone has a
please?
question again.
All
Yes.
right. What is the question,
Vincent.
please?
I think I miss the last stage before you open the RStudio. My network was disturbing me small. Where I think you were downloading the Git and incorporating it into the R.
Yeah. So on
Sorry.
the slide, you have to configure your Git, right? And you can either do it on Git Bash or you do it directly on the RStudio. So here is the RStudio, and you can click on Terminal, right, and start putting all your Git commands. So, for example, to configure it, this is the link. So you just come here, right, and put your username here. The username that you have created on the GitHub website. For example, here. So let me see if I can sign out. Okay, so immediately you enter this website, you can see this is Git. This is GitHub brother. So you click on sign. You click on sign up, and this is so it's either you can sign with your Google or you sign with your Apple or you just manually create your email, your password, your username. But this one here on the username, just try to be concise with the username. Right, for me my username is this, so then your country, and you sign it up, you create an account. So immediately you create an account, you have our username, right? So that username is what you will configure on your RStudio terminal. So you just okay. So now you can see. So this is my own account. Here's my profile. Okay. So if I go to my own profile itself, that is GPG. Let's see. Uh, uh, file. That is. So once you create an account, so your profile will now be your github.com/ your username. So for me, my own is this. Okay. So immediately I click here, you can see. So I also try to create a README file. Okay, that is what you are seeing here. But no worry. If you want to do the same thing, you can just clone this guy, go to this guy, clone it, and edit it, and that becomes yours. So put your handsome and beautiful portrait here. Your profile summary, put it here. And the more you are working with GitHub, the more you'll be having several achievements. For example, you can see I have 2 achievements here. You can see, and I'm a pro user of Git and GitHub. So, because I've collaborated severally on it, you can also, try to do the same today. Because if you are looking for a very good job, right, they will ask you for your GitHub account, or GitHub or GitLab. So if you don't have GitHub or GitLab, or you have GitHub and you're not doing anything, so they may not believe that you can work with version control in their company. So it is good for you to master all of this, and that is why we thank Belekiso, that organized this workshop today. And thanks to the Abuja Arza group. So to configure it, remember you follow this step: git config global space username, put a username there, the same thing with password and everything. So now that you have done that, right, you need to also activate GitHub or your RStudio. And you can do that by going to tools, then go to Git, select this one here, or it will automatically detect it for you, and click apply and click OK. So immediately I did that. So you can see that I now have Git on this panel. So this is the Git. You can see here is the Git, and all those git add, git commit, everything can be done without you mastering the git command. Now you can see I have all these files here. So when I use git status to understand the state of my working directory. You can see all of these things are highlighted as red. So what it means is that these files are not tracked yet. And remember, to be able to have a very good version control system on your project, you have to add all of these files into the staging area. And you can easily do that by using Git, add, and put a dot here. So this automatically add all of this. But the same thing here, you can also do it here. You can see it's putting a question mark here saying that the status are not known. That is why you're having a question mark everywhere here. So to add it, you just click on each of them. As you can see, now. So what this git add dot will do for us is what this guy has done by just clicking on it. Okay. Then the next thing is to commit the changes, right? And you can do that by using git commit -m and put a commit message. What is commit message? So commit message is what will indicate what prompt this action. For example, I'm just adding files, to my project uh, directory, for example. So your commit must be meaningful and must be short, must be concise. So then you press enter. So now to do this, what I will do is to click on this guy. You can see it's saying that commit pending changes. So to commit it, just like what I have done here, if I don't want to use any code, I'll just click on this guy. So if I click it, you can see I will now write the same message I put here. Remember, RStudio is making us to be lazy with, so you don't need to memorize any code. So here I'll just say, what is it now? Added, files to the project, directory, for example. So then you will now click commit. What is it? GPG, way to sign the data, sign it, way, no secret key, way to commit. What is the problem here? What is the problem? Way sign in. Okay. So I'm not understanding what he's saying, but let me try to use this guy. So this will tell me more. Okay, so this as okay, let's see, git status, nothing to comment, working tree clean. So, but I don't know why this guy is refusing my comments. Okay. So if you want to look at your git status, remember you can use git status, and that will show you the current state. And the same thing for RStudio. You just click on this guy, this one here. Just click on it, and you can see it's saying that I added files to my project. That's exactly what I put here. So this one is showing something like git log, right? So git log, you can see this one is git log showing us the history of our project say adding files to the project directory. And the same thing you can also do, without using code. Just click on this guy, and this is exactly what you have done here. Now, since we have added the file to the staging area, we have commit the project. The next thing is to be able to work directly with remote repository. Remember, we need to create a repository, right, on that GitHub. So what we do now, so what I always do is to come here, try to come here, right click, copy, so that I will have the same project file. So I will go to GitHub now. I'll go to GitHub and then create a repository. So to create a repository, what we do is to click on new repository. Now you can see then your repo, because I have several GitHub accounts, both my personal account, our company, or organization account. So it's asking me to choose the owner. So you can see I have this one is R development. This one is TA University that I'm doing. That I'm a faculty, and I'll just choose my own here, GP analyst, and put this guy there. The repository I created, you can see, it's telling me that it is available. So that means that your repository must be unique within your GitHub account. So if you have the same name, it will tell you that this name cannot be used. So you have to use another name. But because I don't have any data visualization repository, so that is why it's telling me that it is available. Then here is description, just a concise description of your project. And if you don't do it now, you can do it later. So I don't want to do it now. The next thing is to look at the configuration, right? Do you want this your project to be visible? So if your project is visible, anybody can see it and they can download it, and that become DS. But if you don't want them to see what you have done, maybe you have sensitive information, data, script, and everything, so you may put it in private. In this case, nobody will be able to see it except you add a collaborator, into that repository. So, but for now, I'm going to make it public. So then we have a template. So I don't want to choose any template. Then this is the README, right? What is README? So anybody that enter into your repository, the first thing they will look at is your README. And README file is what will tell them everything about your project. What is the project all about? How can they work with the project? Is there any license to work with it? What are the rules and regulations guiding your project? That's exactly what README is all about. So, but for now, I don't want to create any README because I have the README already on my project. So I will not create any README. Then I have git.gitignore. So git ignore is helping us because if you push our project into the remote repository, every file in it will enter into the remote repository on GitHub. But sometimes you may not want to add every file into it. So you may want to, so if you use git ignore, that means that such a file will not enter into your remote repository. So that means that such a file will not enter into your remote repository. Sorry, let me. Okay. Please, can you still hear me? Hello, can you hear me?
Yes, please.
Okay. I'm coming, please. Okay. To save my power. All right. Okay. So every file you don't want to be added to your remote repository, then you are going to create a particular GitHub file, GitHub ignore file, so that those the name of those files will be on it, and then when you push it to the remote repository, such files will not enter there. So what I will do is let me create it. Okay. I see now allow me. Okay, no problem. So then the license. So we have several licenses that you can choose from. So this is actually so it will get more important to use license when you have a very big project. For example, if you have an RStudio project, if you have a project, an RStudio package, that you are developing, and you want to give them a license to know how to use it or how to work with it. So you can choose that license here. So we have several licenses such as MIT, such as CC 4.0, and many more. So, but now we are okay with that license. So then we click on repository. Now you can see, so we now have the repository here. Okay. So what we do now is to start copying all these codes. Remember, I have said I don't want to create a README file because I have the README file in my RStudio, which I have created by myself. You can see it on these files. You can see it on these files. Here, if you go to the data visualization, the README file, so you must create a README file for every of your projects. So this is my README. Okay, the title is data visualization project. I explain what it is. Project structure. Your README may not look like this one, but it just contain information about your project. That's all, so that nobody will just, so that people will not be lost when they are in your repository. Okay, so remember we have already created, we have used Git init that helps us to initialize version control in our project. So we now copy this. So the git add.md, this one is when you want to add the readme into your staging area. We have done so before by using the RStudio, the git add. This one here. Where is it? Because already we have added the files to the working staging area, so you cannot see it here again. And we have already committed it. So this one we have done all of this. So we have done this, we have done this, and we have done this. So the next thing is for us to copy all of this. So, but I would like you to copy it one by one. Just right click copy, go to your RStudio. In fact, okay, go to your RStudio, paste. So every git command must start with git. So this is git. Then the next thing is use this git remote, all of this, copy it, come here, this. Okay. Now the next thing, the last one is to say git push, and this will now get everything into this the remote repository. So I just say git push -u origin main. Okay, so for the first start, so you will do this. After that, you can start using git push without using all of this. Okay, so if everything is okay, then we don't have any error. Now you can see it's adding all the files, everything into the remote repository. Okay, so now if I refresh this guy, you will see everything on this repository. Now you can see. All right, you can see here is the README, and this is the beauty of our README. Anybody coming here now can understand what the repository is all about, as you can see. Then, if you like, you can now write your description here. Okay, this uh, this project is is organized by Abuja, or this is a workshop, okay, projects that is organized by Abuja R user group, okay, in Nigeria. So this is just the description that I said that if you don't do it now, you can do it later. All right. This is the URL to this repository. If you like, you can just copy this guy. Okay. And then put it here. And the topics, just like tag. So what is the project all about? So it's all about version control, uh, version version control, version control with Git, R programming or RStudio, all those stuff. Just put it here and click save changes. So immediately you do that, you can see everything here. Now we have about, this is the readme, and we have the link to this project, and we have everything. So if anybody want to start cloning this project now, what they will do is to come over here, click on the code, right? Or let's say that this is your project and you want to send it to your supervisor. So what we do is you don't need to download it. So just send this link to that supervisor via any medium, and the person will just come here and they can see, they will enter into your project. And if they want to clone it to their system, so what they will do is to come here, click on the same, click here, right? Click this guy. All right. So click on this guy, and you can actually clone it with RStudio. So if I close this guy now, if I close this RStudio, if I close this RStudio, and I click on RStudio project, remember RStudio project, new project. If I'm the collaborator, all right, I can clone it. Just come over here, version control, Git, and paste the link here. Project username is, so this one should populate automatically, but it's not doing that. So then I can just come here, okay, copy this guy, put it here, and immediately you click project. That is how to clone project in RStudio. So, but let me put it in another directory. Yeah, let me put it in the document directory, and I click. Let me put it in new session. Okay, don't worry. Let me just click here, create project. Now you can see it's cloning the project. Okay, cloning the project, and now you can see I have the project now. So it's in my document. Now you can start working with it. Okay, so I can start looking at what my students, has done. Okay, this is data input. This is this. This is that. Okay, and yeah, if I'm happy, everything is fine. Now, let's open back to our initial RStudio projects. Let me close this guy. Then let me open the one of Abuja R programming. Okay. Okay. Now we are here now. So any question? Do you have any question for me?
Any question?
From my side, no.
Okay.
Okay,
Good.
thank you.
Okay, thank you.
So I think you can go ahead.
All right, thank you. So now, how can we collaborate, on a particular project? Let's say you have this project, for example, and it's an open source project, and you want to collaborate with it. So how can you do that? So to collaborate with a project online on GitHub, so what you will do is not the way I did it before, by coming here, copy this and start using RStudio to clone it, or by using the command git clone, and put the link here. So this one we also do the same thing that the RStudio project under this new project git, under this new project, this version control this, and you put the link here. We do right now. You can see it automatically gave me the project name. So this is not how to collaborate with a project on GitHub. So to collaborate with a project that is on GitHub, what we do is to fork it. Here is it, fork, as you can see. So forking means that you want to own that project. So let's even read. Let's read what. So if you click on fork, I want to see the int. Okay, you can see it's saying that fork your own copy of GBG analyst slash data visualization. So when you fork it, then you are creating a copy of it into your own GitHub account. So you can see it's asking me. So let's say I want to use this because I have access to it. Now I am creating a copy of it, right? Then I will now click create fork. So immediately I click create fork, you will notice that I now have that project as my own repository. You can see it's no longer GB journalist again. It's now TAU University slash data visualization. Before it was this. This is the right link. Now, because the person has forked it, now it becomes its own. Okay, you can see it now trace it back to me saying forked from GBG analyst slash data visualization. So now that we have forked a project, so what we now do is to start collaborating on that project, not on this guy by cloning it, no, but by this right way. So what we do now is to clone it. So you can see here, you just copy this guy, and of course, you can use RStudio Project the way we did it before. This one here, click on File, click New Project, click Version Control, click Git, and copy this here. Okay, so let me see the part. I want to, let me delete everything I have done under the documents, data visualization. Is it here? This is it. So I want to delete it. Okay, then now I want to take it to my document because I want to collaborate with it. So see me now as an external person who loves that project. And because I know R programming and I like the project and I have time and I want to collaborate with it. So I'll just click on document and then I click open. Okay, so the root folder is always document. That is why it's not selecting document. Okay, the root folder is always document. So now I click create project. Now you see it's creating a copy of that project into my system. Now you will see that I'm now in that new you can see if I say what is my working directory by using get wd, you can see it's saying document data visualization. So now I'm a new person and I love this project, you can see, and let's see how to collaborate with that project. All right, and so remember I talked about Git branch. So the Git branch, the main Git branch now is just our main branch. You can see we only have main branch. Because I want to work on this project, it is good for me to create a new branch so that I will not be working on the main. It's not good. It's very bad to work on a main branch. It's just like I don't even know which example can I cite. Can somebody give me a good example why one should not work on a main branch?
Because maybe if we have problem, we cannot go and verify that.
Exactly. Imagine you are working on this file now. You are working on this file. Okay, you are working on this file. And something happens. Maybe your child come back from school and a baby, a toddler, now start playing with your mouse and start deleting several things, because he's just a kid. And you now, because you don't verify what happened, you just say git add, git connect, all of that, and that has rubbish the main branch. So in order not to have such a problem, or if such a problem exists, of course, it's not affecting the main. You can easily come back to main branch and create a new branch and start working afresh. All right, that is the main reason why we work on the new branch. So I can do that by saying git. I don't like using git checkout minus b, because I like with my brain I can just say git branch. Okay, git branch, then git branch, then I will create the new branch. So let's call it uh, Abuja, for example, Abuja R. Okay, maybe member of Abuja R is the one that want to collaborate with it. Okay, let's call it a good name, Abuja member, for example. Or let's say, okay, let's call it new visualization, for example. All right. So now I've created a new branch, and the name of a new branch is just like the way you are creating a new variable. So it has a naming convention. Okay. So I just say new visualization, and then I can switch to it now. Say git switch, then the name of the new branch. I try to press tab to see several branches, and then I can just copy this. Okay, and then paste it. Then so immediately I switch to a new branch. You can see it has changed the name from main to new branch. So now if I type again git branch, okay, git branch. Now you will see that I am now in my new visualization. Okay, good. So this time around, I want to use renv. So now let's go back to renv to know what is renv. Okay, so this is the last section. I hope you can do it within 5 minutes. So, and it's very simple. Already, we have created RStudio Project, which makes our work to be reproducible. But if you now update your project to have a new version of a particular package. For example, we have tidyverse, right? Let's see tidyverse, for example, tidyverse under the console. Let's type tidyverse package version, something like a version. Is it a version tidyverse? Okay. Okay, if I say tidyverse packages, no, I just want to see the version. Okay, that is a package dot version, something like that. Package version, the one with capital V, this one here. Okay, and I put tidyverse here. Can see here is version 2.0.0. Now, if there's a particular new version and you updated it, right? And maybe a particular function has been removed from that package, from that new package, and you have already used that function in your project, and because you now put this project inside the GitHub, the remote repository, and a new user like Bilikisu, for example, now did not update our tidyverse package. Okay. Remember, okay, no. Bilikisu updated our tidyverse package. Now, let's say this glimpse has been removed. in that new version of Tidyverse. But in the project that you have pushed into the remote repository as an old Tidyverse package. So because Bilikisu has updated our own Tidyverse package, we not have this function available, and there will be an error. So it not be like it works on your system and it's not working on my own system. And that's exactly what this package is helping us to do. And the name of the package is called renv package. So it's just a dependency management tool that creates a project-specific library and ensure that your computing environment is reproducible across different machines. And when you use renv package, it helps you to avoid it was on my machine and it's not working on your own machine, right? Because every version that you use in that package will be automatically installed when the person download the repository on GitHub. And to create this kind of package management with renv, you are going to install the package. It's on CRAN, and you can install it by using install.packages renv. And to initialize the renv package into your repository, you will just use this function called renv. So, for example, remember, I'll just come here. I just say I can load it because I want to use several functions from it. I just call it renv. Now, when you initialize renv, right, it will give you a log file. So, but for now, I've not initialized a renv in my repository. So I just come here, load it. As you can see, it also loaded several functions, and I say init. So init is the first function that will help us to initialize the renv into our repository. You can see it can take some minutes, some seconds. You can see it's loading. So it's linking packages into our project library. You can see it's going to 118. So it can take some seconds. Now you can see it created a particular file called renv.log. So immediately you refresh your panel here, you will see that log file. This is called log file. And if you open the log file, you will see all the packages and their versions. For example, you can see the DBI, you can see this is version 1.2.3, all the packages we have used, this one, Nano Arrow, this is the version, the RSQLite, almost everything you can see is very long. So all these are what it has stored in the log file, so that anybody working with it, you don't even need to download any package when you are working with this project. Now that you have initialized the renv into your repository, the next thing is to look at the status of that project. Okay, so let's look at the status of this project. You can do that by using status. Okay, oh sorry, it's a function. Could not. What is the problem? Git. Sorry, let's use renv status. Okay, you can see. Of course, we can use the function directly, but it's like a particular function is called status from a particular package. That is why there's a particular conflict. So that is why I had to attach the package with the function. So now you can see it's telling us that there is no issues found in our project. So that means that the project is in a consistent state. Now, the next thing now is to now create a snapshot of our project. That is what the next slide is talking about. So, we have logged the file, we have looked at the status, and there's no problem. So the next thing is to, is to type snapshot. So we use snapshot, to lock that file and to update it. So let's use snapshot. Snapshot. Okay, let's try to use renv snapshot. Okay. As you can see, so now we have the snapshot. So anytime you load any package whatsoever, you need to start using snapshot. The first thing is to use init. That is renv init, and it's once and for all, right? But every time you are loading a package, or you are using any function from a particular package, you need to continuously using snapshot to update your log file. So remember, our log file is this rem.log. As you can see, everything is updated. Okay. Now that we have done that, so let's go to our terminal and say git status. So you will see several updates. You can see we have .r profile, we have rem.log, and we have rem directory. And the same thing, you can also do that using the RStudio menu. So click on Git, you can see everything here. And so let's load it. So here is where we are using Git add. Remember, anytime you are clicking this, it's using Git add. It's using Git add. The next thing is to commit it. So click on this file and click commit. Okay. Added renv, okay, into the repo, for example, and you click commit. Fail to come. I don't know why this one is giving me error on RStudio, but don't worry, I'm going to rectify it later. I meant previous comments. No, I don't know why. So I will look at my RStudio later, but you can do that by using the Git menu on your RStudio. But I'm going to use the command interface. So here I'll just say git commit -m. Okay, that is added renv into the repo. For example, what is the problem here? Okay, added renv. Okay, added renv into the repo. Okay, so then I press enter. Then now that I have everything, okay, then I now want to merge it. Remember, I am currently in my new visualization, as you can see, new visualization. Okay, so it is possible you do what is called internal merging, or you just push this guy, the new visualization branch, into the main repository. Okay, by creating a pull request. So I've just because this project is not mine, so I don't need to put it to merge it into the main branch. So but I will go with this one into this new branch. Then I will now push it into into the into this one here, and create a pull request. So pull request is what the main owner will look at, and they now merge it into their own main repository. So let's see that. I think we have just 3 minutes more. Just 3 minutes more. So sorry, I'm taking longer time. So let's just say git, okay, git push, okay, origin, git push origin new visualization. So this our branch. Okay, if everything is fine, let's see what will happen. Now you can see the code is fine. Git push origin. This our if it is main branch, I just say git push origin main. But because I don't have access to the main, so this guy will reject it. So that is why I push my own new branch into this remote repository. So you can see. So if I refresh it now, Let's refresh. So it's loading. Yeah, good. You can see. So now it's asking me to create a pull request. Remember, I have forked the main repository as my own. So now this is TA University. This is their own now. Okay. So because I am contributing into this project, so the next thing is to create a pull request. So the pull request will now go into the main branch and tell the owner that I have contributed into it, and the owner can look at it to see. So you create a pull request by clicking this guy. Compare the pull request. Okay. Sorry, I'm coming. Okay. So now in this new pull request, I can change my title. As you can see, I think this is fine. Added ref into the ref, added ref into the repository. So I can remove this guy. Added ref into the repository. So it's good to greet the owner. Hello, for example, hello Ezekiel. No, thank you. Something very good. Thank you for creating a wonderful project for the community. For example, the Abuja R user group community. Okay, please look into the new into the new. Please look into my contribution. Please look. Okay, I just contribute to the project, by adding renv into the repository. Okay, let me know if everything looks good. For example, something like this. Okay, and then you now create pull request. Okay, so as you can see, so it's comparing it with GP journalist. I think. Okay. Please, can you hear me? Can anyone hear me? Can anyone hear me, please?
Yes, we
Yes,
can hear
please.
you.
Yes, please. We can hear you.
Okay. 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 So I don't know why the network is. Okay. So it's loading, and let's see what happens there. And when we stop, it is time already. I don't know why it's not. So remember, we have already created a pull request. So I think the next thing is for this guy to look at what happens in the project and then merge it into the main repository. So let's see if this will work. It will work, but I don't know why it is not. This guy is throwing. It's not. It's showing an error. Is it my network? What is the problem? Or the server of GitHub is down. This guy too is not loading. Okay. I don't know what happens here. It's because our time is up. Bilekis, is it because our time is up? That's why it's not loading again.
No problem.
So I don't know why it's not. It's throwing GitHub. Is it? Let's see GitHub self. GitHub. I think GitHub is down, so I don't know why. You can see this one is not loading. So please, do you want to check the GitHub account on your browser and to see it's not only affecting me? So, what is the problem? I think GitHub account is not loading. It's not working. Okay, let's see. Google. Okay, is GitHub down? So what is the problem then? Okay, so it's back now. Okay, okay. So it will show me that somebody under this pull request, you will see a particular pull request here. What's the problem? Okay, no pull request yet. So let's try to see what happened here. Okay, okay. Let's go to TAU. Sorry, our time is up. Let me just see if I can take it. github.com/TAU TAU TAU University. No problem. Okay. Okay. So I don't know. I don't want to take us. I don't want to take our time. So once you create a pull request, the pull request will be on this side, and the owner can just work with it and then accept it. You see a place called merge here on the browser. Then you merge it, and then you have contributed to it. So let's look at the player package, for example, so that you can see several pull requests on it. GitHub, dplyr, GitHub, for example. Okay, so this is it. So this is exactly what we try to do here. You can see the pull request, that is about 4 people, right? Have worked on dplyr and they created their pull request. So then the maintainer will now come here and they look at it, verify what they have done. If it is okay, then they merge it. That is where you now have. So whenever they merge it, you then have a new version. So that is why you always have version. A new update is available. Then you update your packages in RStudio. All right. Thank you very much. I think we are done because of our time. Bilekis, over to you.
Thank you so much, everybody, for joining us today. Unfortunately,
the Kiso had to step out to attend to an emergency issue, so I'm stepping in for her. But I want to use this opportunity to thank Ezekiel for a wonderful session, and we want to thank every participant here today for making this session an interactive one. Thank you, everybody. See you next year and enjoy your holidays. Bye-bye. Thank you. Thank you, Ezekiel, once again.
You're welcome. Thank you very much, everyone.
Ezekiel.
Hello.
Please, would a slide be shared?
Yeah, it should be shared. Yes.
Okay. Thank you. Thank you.
You're welcome. Yeah. Bye, everyone.
Bye. Bye, everyone.